Alright, so for this one, we're given the mass, right? So the mass is 4.5 kilograms. And that's attached to a spring in a horizontal circle where the radius is 52 centimeters, but we need to convert that to meters, so it'd be 0.52 meters. And then the braking strength, the force, has to be equal to 767 newtons. What's the maximum speed? So what's the velocity that this can be hurled at, or does it say maximum speed? So this we have to figure out, are they talking about the angular speed or the tangential speed? So you have to look in your formulas, those equations that I gave you, and we'll start with force. How do we calculate the force when we're whirling something around?
Mass times acceleration.
Yeah, but what type of acceleration? Alpha, right?
Yeah, alpha, yeah.
So find the rest of that. So we know the force is equal to alpha, but what is alpha?
Alpha is
Keep going, you got this.
acceleration. Oh. Alpha is equal to W over time.
Yep, so this could be also the mass times omega over time.
It's like a 3-hour morning.
And then there's one more relationship. You almost got it.
MV to the second over R.
Huh?
Is it MV to the second?
Yeah.
Mass times velocity to the second over R?
Yeah, so then this is equal to the mass times the velocity over the radius. So this is what we want. This is our relationship. So over here to the side, we're going to say the force is equal to the mass times the velocity, times the velocity squared over the radius. Okay? Right? Okay, so they're asking for velocity, so I got to move this other stuff away. So I'm going to multiply both sides by r, and I'm going to multiply this by r, and then I have to divide by the mass. This mass cancels, this r cancels, and I get the velocity squared is equal to capital F r over the mass, but I want the velocity, so I have to take the square root of both sides. So I'm going to have to take the square root of the force times the radius over the mass to get the velocity.
Okay.
So then the force was, what was it, 676?
Yeah.
So 676
Oh wait, I think it's
times the radius, which was 0.52 if we do it in meters, and then the mass of the object was 4.5 kilograms. Yeah, get it out of the thing. And we take the square root of the whole thing. Alright, so we're gonna plug that into our calculator and see what we get. So we're gonna do the square root of, and then a fraction, 767 times 0.52. Hold on, let me see. Divided by the mass, which is 4.5 kilograms. So it says it's 9.41.
9.41, okay.
Oh, it's meters per second.
Meters per second, yeah.
Huh?